Slide 1. In the name of Allah, the most gracious, the most merciful.
History of Artificial Intelligence. Slide 3. In 1950, Turing introduced the Turing test, machine learning, genetic algorithms, and reinforcement learning in his paper titled Computing Machinery and Intelligence. He is considered the father of computer science and artificial intelligence, and the most prestigious award in computing is named the Turing Award in his honor. One good way to understand the history of artificial intelligence is to look at the Turing Awards. This list includes names such as Marvin Minsky and John McCarthy for establishing the foundations of this field, Edward Feigenbaum and Raj Reddy for developing expert systems, Judea Pearl for developing probabilistic reasoning techniques, and Hinton and Jan LeCun for deep learning and multi-layer neural networks. The $1 million Turing Award is awarded annually by the Association for Computing Machinery with financial support from Google and Intel. Slide 4. The Emergence of Artificial Intelligence. The first work related to current artificial intelligence was done by Warren McCulloch and Walter Pitts in 1943. They introduced a model of artificial neurons with two states, on and off, and demonstrated that any computable function could be calculated through a network of interconnected neurons, and all logical relations could be implemented with a simple network. In 1949, Donald Hebb introduced Hebbian learning. Every time a memory is recalled or an action is repeated, the neural pathways involved in the connection become stronger, making the action or memory more vivid and easier to reproduce. In 1950, the first neural computer simulating 40 neurons was built. In 1952, two chess-playing programs were created. In 1956, John McCarthy proposed the Dartmouth Conference, where 10 experts and enthusiasts in automatic machine theory, neural networks, and intelligence study gathered for a 2-month workshop to advance artificial intelligence science. The term artificial intelligence was coined at this conference. John McCarthy also invented the LISP language for artificial intelligence. Slide 5. Initial enthusiasm and great aspirations. In this period, the focus was more on what artificial intelligence could do, such as games, puzzles, mathematics, and IQ tests. That's why John McCarthy called this period the "Look, Mom, I can ride my bike without hands" era. Many events occurred during this period, and I'll briefly introduce a few of them like a parrot. The hypothesis of the physical symbol system was presented by Newell and Simon. A physical symbol system has the necessary and sufficient means for general intelligent action. Natalis Rochester wrote the first artificial intelligence program. Herbert Gelernter wrote a program to solve mathematical theorems. Arthur Samuel wrote a game using a method now called reinforcement learning that could play better than its creator. John McCarthy introduced the high-level Lisp language for artificial intelligence during this period, and wrote a paper in which he imagined a hypothetical program encompassing general world knowledge that could execute any program. James Slagle's program was able to solve integral calculus problems. Daniel Bowbrow's program solved algebraic story problems. McCulloch and Pitts also did initial work on building neural networks. Hebb's learning method was developed by Bernie Widrow.
Slide 6. A bit of reality. The beliefs of scientists in the field of artificial intelligence, given the actions and events of the past decades, envisioned rapid and ideal progress. But in this period, as the scope of issues expanded, 3 problems led to the failure of artificial intelligence's growth. 1. Conscious introspection. We were aware of the intelligent entity's response, which included a detailed analysis of the task, the meaning of the answer, and the algorithm's action. I am using a smart navigator. The smart navigator tells me the street is a dead end, but I, knowing that I can pass through with my small car, do so and enter another street. What is the problem? The system has a pattern of streets and routes, marked dead ends, no entry, and other possible street features, all available based on the drawn map. Even traffic maps and road accidents are clear to me. The system is also aware of probable acceptable results to the user and communicates better with the user in colloquial language. But the system has no program for the car's dimensions. When planning the arrival time to the destination, it does not consider your driving style regarding risk-taking, speed, car type, or the driver's adherence to traffic laws. Is a navigation app considered for the police or emergency services? Why don't we have such navigation? 2. Not understanding the unsolvability of some issues. Some issues are inherently unsolvable. The maximum speed of an electron does not reach the speed of light. Imagining surpassing this speed creates issues that must be put inside a box labeled NP and then connected to unsolvable problems in the hope that solving one will solve them all. Imagine living on a planet decades later where surpassing the speed of light is a natural occurrence. Now it's time to take out the mysterious NP box and solve all issues waiting for this to be solved, such as time travel. The belief that the world was created randomly also entered the field of artificial intelligence. If we have an artificial intelligence that stores all possible probabilities and all command codes with small changes in itself, stores beneficial changes for exploitation, and grows them, we can solve unsolvable problems and even create programs beyond human imagination, ultimately achieving superintelligence in artificial intelligence. Thousands of CPU hours were spent with no achievement. 3. Fundamental limitations in basic structures. Minsky and Papert, in the book Perceptrons in 1969, proved that although a simple form of a neural network known as a perceptron can learn anything displayable, this display is very limited. Particularly, perceptrons with two inputs cannot learn to differentiate between two different inputs. Their results led to nearly zero research funding for neural networks. Here, as a researcher, I want to tell you 2 points. First, the book Perceptrons does not address breaking down large programs into smaller programs. Second, the book did not seek an alternative way. Let me give you an example. You are in a very distant past and see several people planning to cross the oceans and reach the other side of the seas, very happy and with a significant budget for this. You then write a book with several chapters, and based on wind pressure, water flow, and many other factors, you prove that crossing the seas with a wooden boat is impossible. And essentially wood cannot do this. You shouldn't plan for anything beyond crossing a river. Maybe considering your knowledge and understanding of the nature of wood, we should expect you to say, now that wood can't do it. What can? But your book only ends with saying that reaching the oceans is just an imagination and cannot become a reality, and with this ending, I don't think anyone will spend money and time on building a ship.
Slide 7. What is an expert system? An expert system is a computer system that mimics the decision-making ability of a human expert. Expert systems are designed to solve complex problems through reasoning with knowledge sets. Expert systems were one of the first truly successful forms of artificial intelligence software. They were created in the 1970s and then proliferated in the 1980s. An expert system is divided into 2 subsystems. The knowledge base, which represents facts and rules, and the inference engine, which applies rules to known facts to infer new facts and can include explanation and debugging capabilities. The first successful commercial expert system, R1, was launched by Digital Equipment Corporation. This program helped configure orders for new computer systems and saved $40 million in 1986. Expert systems grew the artificial intelligence industry from a few $1 million in 1980 to billions of dollars in 1988. Immediately after, a period known as AI winter arrived, during which many companies went bankrupt due to unfulfilled promises. Slide 8. Return to neural networks since 1986. Probabilistic reasoning and machine learning since 1987. Big data and deep learning since 2001 have been growing and developing up to now. Therefore, in the next section related to the current state of artificial intelligence with great respect to the authors of the book, I will explain it. Slide 9. Thank you very much for your time. I hope I have made a small contribution to your artificial intelligence education.